again, just part of our exploration of trigonometry and getting the knowledge down that we'll need and stuff like that. We're going to be looking at situations where, for example, we'll be given that maybe like sine of theta is equal to 1/2. Okay. Given the fact that sine of theta is equal to 1/2 here. And I'm going to further specify, well, actually, no, I'll hold off on that. Okay. I'll hold off on that right now. Okay. So, given this information, right, so this is kind of like backwards from what we normally have been doing, right? Normally, we're given an angle, right, and we want to evaluate sine, cosine, tangent, cosecant, secant, cotangent of that angle, right? So like that's kind of like our goal, like I said, our kind of our end goal. The big reason why we do all these time trig quizzes is to make sure we're comfortable moving between degrees and radians, but then also to make sure that we're good with finding, you know, sine, any of the trig ratios for any of those angles on the unit circle. All right. But now we're kind of doing something backwards. Instead of finding sine of an angle, we're given what the ratio is, and we have to kind of like come up with then, all right, well, if this is true, right, then what is cosine of theta, right? What is tangent of theta? What is cosecant? What is secant? And then what is cotangent? Okay, so we're going to come up with all these other trig ratios here based off just that one piece of information that sine of theta is equal to 1/2. Okay, so any thoughts on that? How might we be able to go about doing this? It would be really helpful. Well, actually, I'm not going to say that. Never mind. I'll hold off. So if sine of theta is 1/2, what can we say here? Any ideas? What cosine is going to be, what tangent is going to be? Any of these other ones that we can get maybe right off the bat, just knowing that sine of theta is 1/2? So yeah, Laura? All right, cosecant has to be 2. Why is that? Yeah. Okay, so right off the bat, boom, we got that. Cosecant theta has to be 2 because sine and cosecant are reciprocals. All right. But what about the rest? What the rest? Like, how can we find it? Draw a picture? Okay, so how might we draw a picture? What do you mean by that?
Draw a right triangle.
Okay.
The theta in one of the corners that's not like the 90-degree angle.
Yeah, okay, one of the acute angles there. So we'll just put theta maybe right in there.
And then you know sine is opposite of hypotenuse, so the one will go across
from the theta, opposite it.
And then the 2 would go on the hypotenuse.
Right. And you don't have to use 1 and 2 here, but that's like the most obvious pairing, right? It doesn't really matter. I could say 2 here and 4 here, right? As long as the ratio of the opposite and hypotenuse are 1/2. So it really could be any combination of numbers that make that 1/2, but 1/2 is the most straightforward. So why mess with it otherwise? Okay, great. So that helps us. So then how do we proceed from here? What do you say, Ethan, from here then?
I don't think this is a special right triangle, so you have to use Pythagorean theorem.
Okay. Okay, use Pythagorean theorem to solve for b, and so let's do that. So it'll be what? 1 squared plus b squared equals 2 squared then is what you're saying?
Yeah.
There, okay, so we get then 1 plus b squared equals 4, and so b squared is 3, and so b equals root 3. Okay, or technically plus or minus root 3, right? But I guess we're talking about a triangle here, right? So we should probably just say positive root 3. Okay, cool. So then, now that we have that little right triangle there, what can we do now with like cosine of theta, for example? What would cosine of theta be? Root 3 over 2, right? Adjacent leg. We know the adjacent leg now. It's root 3 over 2. Okay. What about tangent? Tangent is what over what?
Opposite over adjacent.
Yep, so it would be 1 over the root 3. Or if you like to rationalize, root 3 over 3. Okay. And so then secant will be what? 2 over root 3. Or again, if you like to rationalize, 2 root 3 over 3. And then cotangent will be what? Root 3 over 1 or just root 3. Okay. Exactly right. So that's exactly what we want to do here if we're missing if we're trying to solve these trig ratios here. So step 1, create a right triangle with angle theta. Oh, I'm off the screen. There we go. Create a right triangle with angle theta in it, right? And then fill in the sides using the given ratio. And then step 3, our final step there, use the triangle to find the other ratios, just like we did. Anyone recognize this angle theta?
Yeah.
60?
No, 30 degrees.
It'd be pi over 6. Pi over 6, 30 degrees, yeah. That's okay. We're still learning and stuff like that too. That's fine, okay? But yes, it'd be pi over 6. It'd be pi over 6 here, okay? Now, we did kind of make an assumption, though, that theta was in the first quadrant, right? Because we're not told, like, the initial information that we're given here is just that sine of theta equals positive 1/2, right? So we're assuming that we're in the first quadrant because there's another place where sine of theta is 1/2. What other quadrant is sine positive? Quadrant 2, and what is the kind of like corresponding angle to pi over 6 in quadrant 2? Or what's the angle whose reference angle is pi over 6? 5 pi over 6. So technically here, theta could be 5 pi over 6. Okay? And if that was the case, right, then some of these would be negative. So for example, cosine of 5 pi over 6 would be negative root 3 over 2. Tangent would be negative root 3 over 3. Cosecant would still be positive because it's just a reciprocal of sine. Secant would be negative, cotangent would be negative, right? So how are we supposed to know here? Well, in this case, it doesn't really specify one or the other, and so we'll just assume quadrant 1, okay? But if it did specify theta's in quadrant 2 or something like that, you want to watch your SIGN signs, right? Whether it's positive or negative, okay? Keep that in mind. Sine is positive in quadrant 2, but some of these other ones would be negative. Okay? So do be careful with that. But in here, since it's not specifying which quadrant we're in, we can't assume both. Sine's positive both in the first and the second, right? Don't assume both, so we'll just assume it's in quadrant 1 here. Okay? All right. Excuse me. So here, let's have you guys try one. So try this one. Tangent of theta is equal to 3. Okay? Tangent of theta is equal to 3. So I want you to find sine, cosine, cotangent, cosecant, and secant. hopefully you got something like this. Tangent theta is 3. So what does that mean? Well, sine then has to be 3 over root 10 or 3 root 10 over 10 if you rationalize. Cosine 1 over root 10 or root 10 over 10. Cotangent 1 over 3. Cosecant root 10 over 3. Secant theta root 10. Okay. Is this on our unit circle? No, right? None of these angles, none of these ratios, right, live here on our unit circle, right? So this would not be an angle on our unit circle, right? Something that you would not be responsible for finding the theta value of and stuff like that. So unlike this one, where we did have these familiar ratios, we were able to say, oh, theta is probably, pi over 6 there, or some coterminal angle with pi over 6. Here, right, these aren't on a unit circle, so we're not going to be responsible for finding out that theta, okay? At least not without a calculator, okay? So, all right, change it up here just a little bit. Question?
How did you get 1/3 for cotangent?
Cotangent, well, so cotangent is the reciprocal of tangent, right? So I just did the reciprocal. You also could have done, I guess, did you do like cosine divided by sine?
Yeah.
Okay, so that would work too, but it should simplify still to the 3 or to the 1/3 if you do simplify there. Okay. So, but yeah, I just did the reciprocal tangent there. All right. Change it up just a little bit here. Okay. Let's say we've got now cosine of theta equals x over 3. Okay, just a little bit. And this time I just want us to find sine theta, cosine theta, and tangent theta. Okay, so just find those 3. Now, of course, we already got cosine of theta, right? It's cosine of theta is x over 3, so we got that. Okay. But I still want us to find sine of theta and what tangent of theta would equal if cosine of theta is equal to x over 3. So we'll do the same thing as Ethan said before. We'll set up our little triangle here. Okay. Theta in one of the acute angles. And so with my theta here, that means my adjacent leg would be this leg right here, and that's going to be x. Okay, and then the hypotenuse, right, it has to be 3. Okay. And so with that then, if leg's x, hypotenuse is 3, then I can find this missing side using the Pythagorean theorem again, right? So we have x squared plus, I don't know, I'll say b squared again, equals 3 squared. Okay, and so then I get b squared equals 9 minus x squared. Okay, again, I'm solving for this missing leg right here, using b as its label. Right? And then so b equals, again, technically it should be plus or minus, but we're just going to assume, since we're talking about a triangle here, and we're not talking about any sort of quadrants or anything, we'll just say positive. Square root of the quantity 9 minus x squared. So this leg over here will be represented by the square root of 9 minus x squared. Okay, that's kind of the best we can do, given the information that we have. Okay. So with this being said then, what is the sine of theta going to be? What is sine of theta going to be? What's that ratio going to be? What over what? Or what will tangent of theta be? Well, according to SOHCAHTOA, sine is what over what? Opposite of hypotenuse. What's opposite of theta? Yeah, root 9 minus x squared over the hypotenuse of 3. So there's what we can say about sine. If cosine of theta is x over 3, sine of theta will be that. Root 9 minus x squared all over 3. Okay. Tangent of theta as well. Tangent of theta, what will that be? Bless you. Yeah. Root 9 minus x squared all over x, just like that. Okay. And so that's the best we can kind of do there, given that we have just the variable. Okay, so let me give you guys one more to try, and then I have one more problem I want to show you here too. Okay, so one more for you to try, and then one more for us to do together here. Okay. All right, example, or not, this is for you guys to try. Never mind. Try. There we go. cotangent of theta is equal to x plus 2 over 7. Okay, so cotangent of theta is equal to x plus 2 over 7. And I want you to find sine of theta, cosine of theta, and tangent of theta. Okay, given that information there. Only sine, cosine, and tangent, please, given that cotangent is x plus 2 over 7. Okay? Right. So this is right. That's good. But I see what you're saying there. But the problem is that these try making the triangle here and see if that works out the way you think it does. I would say. So in other words, you know, tangent. So if you put your theta here, we put 7 there, right? X plus 2 there, and find what that C would be. Sure, I'll show you. So, let me do it using stuff that we're familiar with. So, for example, if we have like sine of pi over 6 and cosine pi over 6, okay? So, sine of pi over 6 is 1/2, and then cosine pi over 6 is root 3 over 2. Okay, so tangent of pi over 6, all right, sine over cosine. So we end up with this kind of division, we end up with 1 over the square root of 3. You see what I'm saying? So the denominator of 2 cancels out because both sine and cosine have that denominator of 2. And so you have this like hidden value for the hypotenuse. Yeah. No, I see. So in other words, right, that's why it's important you draw the triangle out. So I see what you're saying. It's good thinking, you know, trying to just like, you know, be efficient and stuff like that. But yeah. We need to find the actual hypotenuse though. Okay. Oops. So yeah, okay. So, right, in this case, which one of these 3 can we do right off the bat? Yeah, the tangent, right? What is it? Yeah, 7 over x plus 2, right? Easy peasy. All right. Then, from here, right, we really need to draw a triangle here, all right? We want to be very careful because, yes, cotangent is cosine over sine, right? So, we could say, like, oh, cosine over sine. So then cosine is just going to be x plus 2, sine is going to be 7. But we got to be careful because we have this right triangle that we want to try and draw here. All right, that relates all these things. So 7 will be here, right? The x plus 2 here. And for this hypotenuse, then, it'll be x plus 2 quantity squared plus 7 squared equals that hypotenuse squared. And so we end up then with c equals the square root of x plus 2 squared plus, well, I'll just make that 49. It's easy enough there. Okay? And so with that, okay, that's our hypotenuse. And so sine then is going to be 7 over that root x plus 2 squared plus 49. Okay? Or if you multiply this whole thing out, it's what? X squared plus 4x plus 53, I think? So yeah, so you could have that as well in your denominator, root x squared plus 4x plus 53. And then this will be x plus 2 over root x plus 2 squared plus 49, like that. Okay, and so there are your 3 solutions there. Questions on any of that? Okay, so again, in all these cases, right, we're assuming that we're in that first quadrant. We're not told any identifying information to specify a different quadrant, right? Cotangent, you know, it could be positive or negative really here, depending on what x is. So it kind of like, you know, doesn't really, it's not really necessarily helpful. I mean, I guess, yeah, we could be specified still, but anyway, we're not told what quadrant we're in, right? Cotangent is also positive in quadrant 3, right? So we could be in quadrant 3 here if we're assuming cotangent is positive, but again, we'll just assume quadrant 1 because we're not told any other identifying information. But let's see what happens, right, when we do end up in other quadrants, right? So I'm going to give you a different kind of question, but what we're going to do is going to be very similar to what we were just doing here. What we just did right there, okay? So another kind of like way or another kind of like format of this kind of same idea is to be asked a question like this. Find the trig ratios, okay, given the terminal side of angle theta goes through, okay, or you might see the words something like, or has coordinates of the point -3, 4. Okay, so we're going to find the trig ratios given that the terminal side of angle theta goes through or has coordinates of -3, 4. Okay, so unlike the previous ones, right, we are given no trig ratio to start us off, right? We're not told sine of theta is this or tangent of theta is this. We're just given a terminal side to theta. And our terminal side has coordinates. So that means we're in the coordinate plane here, right? We're in the coordinate plane. So I'm going to draw a little sketch of our coordinate plane. Okay, there's our x-axis, there's our y-axis. And of course, angles, right? When we're talking about an angle in the coordinate plane, the vertex of that angle, where is it located? At the origin, right? We always locate our angles at the origin when we're talking about just angles in the coordinate plane there. Okay, right? And then our terminal side. So remember, our starting side of our angle will always be the positive part of the x-axis here. The starting part will always be right here, right? But then the terminal side, that means how much it opens up to. And so we're going to go through the point -3, 4. So I'm just going to kind of eyeball here. We'll say, you know, okay, there's 1, 2, 3, and there's going to be 1, 2, 3, 4. And so the point right there, the terminal side of my angle is going to go right through that. So I'm just going to draw like a terminal side of the angle there. Okay? And so that's the angle theta that we're talking about there. Okay? But of course, talking about sine, cosine, tangent, cosecant, secant, cotangent of an angle theta like that is a little bit harder to wrap our minds around because we kind of think about sine and cosine and tangent in terms of right triangles, right? We think in terms of right triangles. And that angle theta there does not create a right triangle. Or does it, right? Because we can use this reference angle instead right here. put like theta in quotes there. Okay, so yes, while the angle theta is really made up of this original side right here, and then rotating around to the terminal side that goes through negative 3,4, okay, we're going to instead use that reference angle there and call that theta instead. And it's going to result in the same kind of problem, or the same kind of, you know, answers and stuff like that, just like we do when we have that unit circle and stuff. Okay, now with our right triangle here, we have some things we can label, right? So again, our theta, our angle theta is right in here. It's this little acute angle right here at the origin. What's the length for this side right here? What is this side's length? 3, right? Because we had to go 3 to the left there, so we'll say that's 3. Okay. What is this side's length right here? 4. And of course, knowing that it's a 3, 4, what's the hypotenuse going to be? We can use Pythagorean theorem, but yeah, it's going to be 5, right? 3, 4, 5 triangle, Pythagorean triple. Okay. So now, well, we can just come up with our trig ratios here. So sine of theta, what's that going to be? Sine is what over what? Opposite of hypotenuse. So what will it be in this case? 4/5. Okay. What will cosine of theta be here? Okay, so yeah, we'll get to the sign here in a second, but Ethan is right. It is going to be a negative 3/5, and we'll talk about why that is in a second here. What about tangent of theta? Negative 4/3. That's right. Okay, and again, we'll talk about why it's negative here in just a second. Sine, cosine, tangent. Let's do cosecant, and then secant, and then cotangent. Okay, and these are pretty easy. Once you get sine, cosine, and tangent, then these are going to be real easy, right? What's cosecant going to be? Yeah, 5/4, right? Just the reciprocal. Secant will be negative 5/3, and then cotangent will be negative 3/4. Just the reciprocals. Okay, right. So, why do we need to concern ourselves with whether our ratios are positive or negative here? Why do we need to worry about? Why is cosine and tangent and secant and cotangent? Why are they all negative? So, Ethan? Yeah, our angle here, even though we're using the reference angle, even though we're using this reference angle, our angle, okay, is in the second quadrant, okay? And so since we're in the second quadrant, right, remember sine and its reciprocal cosecant are positive, right? Our y coordinates here are positive, the x coordinates are going to be negative. So cosine and secant, because they're made up just the x coordinates there, they're going to be negative. And since tangent and cotangent are sine divided by cosine, or for cotangent, cosine divided by sine, we're taking a positive and dividing by a negative, or vice versa. And so that also creates a negative there, okay? So that then gives us the quadrant 2, signs and stuff like that, SIGN signs, okay? If you don't have to worry about that, another alternative here is to keep in mind the signs of your coordinates when you're labeling this. So if you want to, you could say, oh, well, really that 3 was a negative 3, and this 4 was a positive 4, okay? And then when you use Pythagorean theorem to find the hypotenuse, it'll always be positive 5. You could use that, and then that'll kind of like take care also of all of your angles, right? Sine of theta would be positive 4 over 5, but cosine will be that negative 3 over 5. It's kind of fuzzy math because we are talking about the length of a triangle there being negative 3, but it still kind of works out because of the coordinates and stuff like that. Okay. So if you don't have to worry about whether being in quadrant 1, 2, 3, or 4, you can just label it with the, with the correct sign, SIGN sign, on your triangle. But the quadrant's pretty straightforward. Just all in the first, cosine or sine and its reciprocal are positive in the second, and then tangent and its reciprocal cotangent in the third, and then in the fourth quadrant would be cosine and its reciprocal secant. Those are the positive ones. Okay? Questions on any of that? All right. So that's all I've got for you there. All right. That's it. That's all, folks. Okay. So, remaining time in class, you can work on the homework. Alrighty. Or if you want, you can also, get down that unit circle stuff too. If you're still not feeling comfortable about it, and the tomorrow's time quiz is intimidating to you.